Good evening, ladies and gentlemen. My name is David Thoreau, and I have the privilege of being the president of the Independent Institute. I'm delighted to welcome you to our program this evening. As many of you may know, the Independent Institute holds programs like this, debates, lectures, and other presentations, which we call the Independent Policy Forum. And tonight we're greatly pleased to welcome two distinguished scientists, Dr. Willie Soon and Dr. Elliot Bloom, who will be speaking tonight on global warming, fact or fiction. And I want to especially thank Dr. Terry and Mrs. Carolyn Gannon for their wonderful assistance in making tonight possible. So thank you very much. For those of you who are new to the Independent Institute, you'll also find information in your packet about us. I also point out that in keeping with tonight's topic, we included 5 summaries of papers by Dr. Soon in your packet, as well as a copy of the testimony by Dr. John Christie, who is from the University of Alabama. And I'll make a mention about that in a minute. Dr. Christie gave the testimony before the House Committee on Science, Space, and Technology. He's a distinguished professor in his own right of atmospheric science and director of the Earth System Science Center at the University of Alabama at Huntsville. So I hope you'll enjoy that. And that material, I think you'll see, be quite relevant to our discussion this evening. Independent Institute is a public policy research institute. We have about 140 fellows. We produce lots of books. We also produce the Independent Review, and there are some sample copies out on the book table. We're thrilled also to feature a book this evening called Hot Talk Cold Science by one of our research fellows. His name is Fred Singer. Anyway, the mission of Independent is to boldly advance peaceful, prosperous, and free societies grounded in a commitment to human worth and dignity. And the results of that work does result in the books and publications I mentioned, as well as organizing various conference and media programs like tonight that we're delighted to be hosting. The issue for tonight is one of great dispute, a lot of emotion, a lot of contention. The major presentation this evening is going to be by Dr. Willie Soon. I should mention that the issue of global warming sort of boils down to a number of questions. Is global warming real? Are man-made CO2 emissions a dangerous, imminent, and irreversible threat to life on Earth? Have such predictions been scientifically established? Have the forecasts from the many CO2-based climate models been right? And if not, why not? What about solar influences on climate, including on the clouds, on the oceans, on wind? And what would massive carbon taxes, or perhaps the Green New Deal and other controls, produce for the people of America and indeed the world, especially the poor? Dr. Soon himself received his PhD with distinction in aeronautical engineering from the University of Southern California. He's been an astronomer at the Mount Wilson Observatory, a senior scientist at the George C. Marshall Institute, senior visiting fellow at the State Key Laboratory of Marine Environmental Science at Xiamen University, and professor of Environmental Studies at the University of Putra in Malaysia. He's the author of a number of books, as well as over 90 scientific papers. He's a recipient of the IEEE Nuclear and Plasma Science Society Award, the Rockwell Science Hunt Award, the Smithsonian Institution Award, the Courage and Defense of Science Award, and many others. The renowned physicists Freeman Dyson and William Happer, both with attachments to Princeton, have both claimed Dr. Soon for his exceptional, courageous, and indeed path-working work in and passion for science. So it gives me great pleasure to welcome Dr. Willie Soon.
Thank you all for coming tonight. I hope everybody can hear me, yes?
Yes.
Okay, but if it's a problem of the accent, you just blame it on alcohol. I tend to have this tendency type of language. Well, I really thank you all. You know, it's full house, right? I mean, my typical size of audience is 5, so I really, really humbly appreciate everybody for coming. My job is rather easy tonight because I want to talk about this gas, this satanic gas, we will call it, you know, this satanic gas called CO2, carbon dioxide. And the carbon dioxide, according to the wisdom of what you call the United Nations Intergovernmental Panel on Climate Change reports, that says that if you were to keep putting this carbon dioxide into the atmosphere, the globe is going to warm, the sea is going to rise, the polar bear is going to say, stop drinking Coca-Cola and say goodbye, and many, many other problems, by the way. Your kids will get ADHD, all kinds of problems. There will be more marijuana and all that stuff, you know, so on and so forth. I'm here trying to tell you that this CO2 is not that powerful in that sense. The only thing it does to the system is actually make the planet greener. So I apologize if this really bothers anyone. And I also wanted to say that, you know, in the spirit of science, I will at least try to tell you that if there's anything that I say offend anybody, I humbly apologize first, because I tend to have the tendency to be a bit more hyper-excited. But my passion is very sincere. It's all about science. All the way down, it's all about science, nothing else. Because if I were to be wrong and say anything that's not truthful, you just hang me right here, right? No problem. Let's just talk about it. If there's anything that we disagree, let's talk about it. And most important of all, if anything that is not clear at all, you all can look for Independent Institute, Terry Gagnon, my good friend. In fact, I also want to acknowledge my 3 Irish colleagues from Ireland. These are the most excellent scientists I ever had the privilege to work with. And we're going to have a team to try to discuss what this CO2 claim by all these world experts, that it turns out to be not so. The most important lessons about science is clear, right? I mean, I have a quote here by Professor Richard Feynman. He's among the finest physicists America ever seen. And it's really to try to get to the essence that science is not about consensus. Have you all heard about that consensus business? 97%. I mean, the kind of stuff they're pulling is very, very bad, actually. All this 97, 99% consensus, it means nothing. It's all about actually asking a simple question like, do you think that climate will change? Of course. I'm one of those 97%. You know? It's just pure nonsense. It's nothing about science. Science is about what are the facts, what are the evidence, and so on and so forth. There is a very famous statement by Professor Albert Einstein, I hope we all heard about him, right, to say that when he published his stuff on general relativity, there's this 100 Berlin academician who wrote a report against Einstein relativity. And the guy with the wisdom by the name of Einstein say, why would you even need 100? If I were to be wrong, 1 would suffice, right? In my humble opinion, after studying this topic for close to 30 years now, that really, this quote is very meaningful. There's never been something about the scientific field that they really try very, very hard to make sure that you all don't get swayed away by people like myself, the deniers and so on and so forth, that, you know, you make sure that you don't hear us. So I thank Independent Institute for providing this forum. I hope I don't embarrass any one of you. They really try very hard. And then every time that you say, though, you want to, I want to ask a question. No question. You just believe us. Every time you say, can we have a little debate? I don't understand your facts. Can you explain to me? They just say, no. Al Gore says so. So we go to this next one. It's another one. One of the world experts is the EPA air chief.
Freedom, responsibility, openness of government, etc. Let me ask you, what percentage of the atmosphere is CO2?
What percentage of the atmosphere is CO2? I don't have that calculation for you, sir.
Maybe you could tell us what your personal guess is on what percentage of the CO2.
I don't make those guesses, sir.
You're the head of the EPA and you don't know? You have all of these laws based on, you're going to get your staffer to tell you now. But you're the head of the EPA and you did not know what percentage, and now you are basing policies that impact dramatically on the American people, and you didn't even know what the content of CO2 in the atmosphere was, which is the justification for the very policies you're talking about?
know that
Well,
that
thank
is-
you.
If you're asking me how much CO2 is in the atmosphere, not a percentage, but how much, we have just reached levels of 400 parts per
I think I
million.
was very clear what I was asking, and I was very clear you didn't know. Let me ask you if CO2, from what I have understand,
I think let's go. That's enough. It's to make a point. These folks want to regulate. They don't want to even study science, right? It's so hard. I mean, sorry, you know. I wish I can be a jellyfish someday. Well, we have a problem in the West, right? It's been known that there's all this wild-ranging forest fire is damaging our homes and so on and so forth, right? Whatever the reason is, apparently the Professor Jim Hansen from NASA Goddard Institute for Space Study, by the way, you all know who he is, right? He's the father of global warming. He's the man who testified in the Senate in 1988, making a clear statement that he's 99% sure that he has already seen the global warming effect by the carbon dioxide, okay? This is telling you the level of stuff he's doing. He's presenting this talk to show that the forest fire numbers burned in the areas has been increasing, okay? And he showed data from 1960 to about 2017 or so. And this is based on a talk with children, okay? Students at the symposium in Taiwan. And I have to say that, you know, that seems very convincing, isn't it? If you are a big authority coming from America, former, you know, NASA director. But I think that God is angry right here, right? You know, something is burning. But the problem is, he's pulling such a childish sort of thing. He put actually a link to the data set where he got it from. But he forgot that the whole data set is available from 1926 or so. Why would he do such a thing, you know? He basically, you all understand, right? He was showing you only that little part, but he forgot to show you from 1926 to 1960. Isn't that childish? Are we serious about science? And these are called scientists, right? And I'm not supposed to tell people about this? I don't even know why he bothered to do this, actually. So, Professor Hansen, hello? But what happened when you do bad science? This is part of the stuff that I have passion about. You know, when you mess around with science, you mess around with me, right? What happened? Well, you got award. I don't care how many awards he wins. It doesn't matter, okay? It is that kind of problem, the reverse incentive science. You're not only not doing science, you have to do something anti-science to get an award, right? So these people, are, to me, they're just burning everything away. You know, it's dangerous, dangerous. Don't do that, man. Because life is much more beautiful than that. One should not do that. This is just a sneak preview on my own study with my friend from University of Mexico by the name of Victor Velasco. We've been looking into the forest fire statistics. This is simply just to show you that the wildfire statistics from about 1930s or so until now, and then we make a forward forecast. We analyze the data. It turns out that the data has very strong, what you call, every 10-year kind of cycle. It has also every 40 years kind of cycle. And then we train the computer using some of this algorithm called artificial intelligence to actually make some forward forecasts, just simply to show that you can do some of this exercise. And I don't mean that I already know everything, but this is just an example of what science is all about. And then we know that it's summer now, so I'm obligated to show this chart from Professor John Christie of University of Alabama, Huntsville, is to show you all this record daily hottest temperature in United States. United States has a very good temperature record, so we can go back about from 1895 until now. You can see it's been changing up and down, but then what we have now is just what it is. That's all it is, right? It has nothing to do with this, because they tend to use that, oh, every time there's a heat wave, it has to be global warming, right? The next one I'm going to show you is that the cold wave, when you have excessive snow. This shall be done by the former science advisor to President Obama by the name of John Holdren. That's what he says. He says that with global warming, we're going to have more cold extreme. Please make sure you understand that facts. But I like to remind who John Holdren is, right? John Holdren is one of those that, in my opinion, has been very much an activist from day one. Of course, that's the only reason why he got selected. But he's by President Obama, and then he's the kind of type to say that you have too much energy is kind of bad for people, right? Because we'll be like giving little kids a machine gun, yeah? So it is known, and this is even cited in scientific literature because he's a very well-known character, right? He's a science advisor to the president. So in scientific paper, people even cite him that saying that with global warming, we're going to have extreme cold wave, okay? But it is known. Look at what the titles say, right, of this scientific paper. That say that we actually will have a lot less cold extreme, isn't it? That kind of makes sense, right? But every time there's a cold wave during the winter, they send out guys like John Holdren coming to defend this status quo of their facts. Another paper by more distinguished scientist, Tapio Schneider, is among the best climate dynamicists from Caltech. Clearly also say that global warming will lead to less frequent cold outbreaks in Northern Hemisphere winter. That's basically what science say. He probably didn't want to call out to find out the answer, right? And worse yet, it is well known that IPCC themselves is actually saying that they have long predicted that when you have global warming, you ought to at least have less snowstorm, isn't it? So if you don't believe me, this is what IPCC say. Milder winter temperature will decrease heavy snowstorm. So this is the type of political game and so-called experts are selling to the rest of the world. And of course, this joke is basically, yes, it's going to cover up the dead bird. The next statistics I'm going to show you is about hurricane. TC is tropical cyclone, the activities, going from about 1970s to now. The reason why you start in 1970 here is because this is the satellite era where we have satellite to look at all the statistics, so it's rather more accurate. But the point is, where is the killer trend? You look at anything you want, right? Tropical cyclone or extreme hurricane, they're going up and down, up and down, up and down, right? Where is the carbon dioxide alcohol? And then if you look at the more relevant, the impact type, the tropical cyclone that actually land on the, come to the land and sort of cause damages. Category 1, 2, 3, and 4, these are 3 and 4 and 5 are of course bad because the wind speed is high, probably a lot more rain as well. It's pretty much up and down, really. This is the stuff that they actually will create all kinds of so-called papers, scientific papers, to try to make claims that, CO2 can actually not change the statistics, but may make the hurricane stronger and more energetic and things like that. But unfortunately, it's not so true.
Okay, picking it up here in Wilmington, North Carolina, right at the Intracoastal, and we're in one of these bands. This is about as nasty as it's been. We had some bands like this last night, and then the eye wall this morning, we were not on TV. It was a dark and raucous night at the hotel, and this wind.
Because the other day, we have this tropical storm, Barry, just move in so you can see the statistics for yourself. If you look at all the landfalling hurricane in Louisiana, for example, the statistics go rather far back, right? 1851 until July 13 of 2019. I don't think you can claim anything out of this sort of thing. Nature is what it is, actually. As far as concerned, we cannot find any carbon dioxide fingerprint in all these statistics. So one other thing that we want to learn is always like that. You really, every time you hear a word, no wonder they say, for example, some people worry, why am I showing so many charts? Because you know why? Words are very bad because they are able to deceive you. You have to learn them. Every time they say this and that, you ask them, where is the data? I want to see the data. My good friend from Ireland say, where's the data, right? Let's look at the data. The first data I want to look at is tornado, for example. This is among the 3 strongest. The one that is tornado that is up to 140 miles an hour kind of wind, up to 200 miles an hour kind of wind. F3 to F5. And showing you the statistics from 54 to now. I don't know. I mean, maybe they like to say global warming causing the trend to go down. Oh, no, it's not possible. It's not possible. Joking aside, you have to study this issue carefully. And then my good friend, the meteorologist Joe Bastari, who say that, especially this 2019, we have a lot of tornado in the Midwest. But the blame on global warming is completely baloney, right? Because this May was very cold, by the way. So to form tornado, you need very sharp gradient, like very warm in the tropics and then very cold on the land here. Then you possibly can have that. Because just a year ago, the May was very warm. Here's the slide that you should see, right? On your left is the one that last year. When you are very warm on the land, you got no tornado activity at all. in the May. But this year, kind of very cold in the Midwest, you tend to have a lot more tornado formation. It's just the opposite of what they say, by the way. Now I want to talk about, because, by the way, this carbon dioxide changing any of the weather and climate statistics, they just couldn't find too many of this around, by the way. To be honest with you, if I can find one, I will show you tonight. I couldn't find one. That's my thing. You can ask all my friends here. They're all scientists. We're practicing science day in, day out. We're looking for these things. Now I'm going to talk about a new scare. It's called osteoporosis of the sea, okay? This is actually a quote. The osteoporosis of the sea, by the way, language manipulation is one of those. I actually told Al Gore, you are the manipulator of the English language. That, you see, things like that. They say they create this thing to create the mental picture. They want to make sure you understand, you know, when you don't have carbon dioxide, global warming, when the carbon dioxide in the atmosphere tends to go down into the ocean, it's going to make the ocean more acidic. Ooh, scary, right? So one of these so-called marine biologists, who is also a Obama appointee, Under Secretary of NOAA, Dr. Jane Lubchenco, who is actually now back at Oregon State, saying that, you know, any plants, anything that have a shell, if you have more of this stuff, like oyster and crab, they will be actually melting away because it's more acidified. It's scary. So, you know what? It's very simple. You just do an experiment. The first thing we do is that we're going to study this lobster under the condition of 400 parts per million carbon dioxide. By the way, that's 0.04%, right? You breathe out, it's almost 4%. So let's ask ourselves, if we run the experiment 7 times more, which is about 2,800 parts per million, what happened to the lobster? It grew bigger. Oh, what's wrong with that? The second one we can test is crab, because they mentioned lobster and crab, so I'll show you that. 7 times, it's also grow bigger. You know, I must be pulling a stunt. Remember what I just tell you. This is an experiment, actual experiment being conducted. In science, experiment means what? You, any one of us you want to do, we just go do it. Just be careful with your experimental procedure, okay? And the problem is there are a lot of these kind of scary things around that you probably have seen. I will show you one. You know, dissolving cell picture, you probably have seen those. Al Gore has used those, obviously. Lubchenco has used this. Jane Lubchenco, the NOAA secretary, show a picture like this from day 0, day 16 to day 45. The shell was very nice and shiny, and then it's kind of eroded away. Willie Soon is lying to you. Well, go home, refund, boy, pay money back. Unfortunately, this is another one of those magic tricks. They did not conduct the experiment that you have carbon dioxide and then they bubble through the system and then cause the change in the carbonate by carbonate cycle, so don't study chemistry tonight, but something like that. You have to study this properly. Instead, what they do is that, as I put a quote here, I better not me talking about it. These are all experts studying all this topic. Guess what they do? Instead of letting the CO2 bubble through the system, they put weak hydrochlorics to speed up the process because they don't even want to wait for the equilibration of the system. Those experiments that I show you takes about 2-3 months to work properly, okay? And they do that. You don't want another one. This someone was famous because in the newspaper she quoted that she's an Obama supporter. Things like that, supposed to gain more credibility, right? I don't care. Just be honest in science. You never ever tell lies, okay? And then, yes, this is just one more extra quote just to make sure that you understand, because these people have been running Japanese too. Japanese probably not influenced by US politics, right? They also show that they have run those experiments by just adding weak hydrochloric acid instead of running the carbon dioxide to show the effects. So every time when I see this, I remind myself on this, going on this road. So be careful, there's always sharks around. So let's get back to global warming, right? This is the typical graph they show from about 1880 to now, let's say, right? You measure that, oh, the globe is warming. If you show the relationship with carbon dioxide, oh my God, did you see it? It's almost a perfect correlation. If you plot the carbon dioxide on the horizontal axis, the global temperature on this is perfect correlation. Finish, clap hand, guys, clap hand, come on. We all know, another important lesson in science, right? Correlation doesn't mean causation, right? If you really believe that this is to be true, I'll close door, I'll go home now. Really, seriously. Because you know why? I told Terry that I want to get a lot of chocolate, I throw it to all of you guys. Because according to some statistical study, that the more chocolate you consume, the more chances of you winning Nobel Prizes, guys. Yeehaw! Anyway, prizes are the most deceptive business about science, actually. Well, let's study this carbon dioxide, right? Let's study that within the context of energy flow within the climate system. The first reminder I want to remind everybody is that it turns out that this climate is among the most misunderstood subject, because Al Gore, the average D student, thinks that he understands climate. My God, it's as sure as gravity. He always say that. You guys are just denier, right? But to understand climate, you need to study what? Astronomy, solar physics, geology, geochronology, geochemistry, sedimentology, tectonic, paleontology, paleoecology, glaciology, climatology, meteorology, oceanography, ecology, archaeology, history. And that's not even complete. And these guys say that if we just change the carbon dioxide content in the atmosphere, that we're going to control the whole system. It's a bit ridiculous, actually, right? And then when those people say that, what's the difference between weather and climate, right? They always say, oh, climate is something like, because according to World Meteorological Organization, it's 30-year average of the weather. That may be very nice to teach students. It's true, you need to give them pedagogical aspect, which means long-term averages. But who says 30 years? It could easily be 50 years, could be easily be 100 years, right? This is all the kind of stuff that is, not quite the truth. It's only half truth, right? Do we just really want to learn half truth all our life? Half truth plus half truth, it really doesn't add to a truth, right? It's actually a pure lie. You cannot send a man to the moon like that, okay? It's a joke, actually. Be serious. Science is very serious. So greenhouse effect, well, I'm not going to explain it because my friend going to kick me because we study this issue very carefully. But the idea is that you added more carbon dioxide molecules, it's interact with the energy flow in the climate system, and if you have more carbon dioxide, you will tend to warm the climate, okay? So let's study this carbon dioxide. Who thinks that the most important greenhouse gas in the climate is carbon dioxide? Oh, very smart audience. It's X, yeah. It's actually H2O, really. It's water vapor, right? In all forms. In the vapor, snow, and ice, and liquid form, right? That's, in fact, half of the job. If we want to study climate change and all that, you really need to study hydrology, okay? And just to give you an example, don't mind the complexity. All the arrows is meant to tell you that, please don't get confused, but then it's to try to show you the climate is really complex, okay? And I'm going to show you, if I click all the individual components and compare the role of carbon dioxide and water vapor in the climate system, let's say who is in charge, right? So first thing we go is we keep clicking. All the blue one turns out to be controlled by water vapor. Okay, snow area, ice area, surface vapor pressure, relative humidity, soil moisture, evaporation, everything is blue. And then they say that if you just change the carbon dioxide, that you're going to get that. You're going to control the climate system. That's basically what it is. And then when it comes down to water vapor, they occasionally like to put a picture like this. The one from power plant, right? By the way, please understand, you cannot see CO2, okay? Some kids from Sweden, the lady named Greta Thunberg, say that she can see carbon dioxide, actually. This is how bad it is, right? Instead of going to school to learn that carbon dioxide is in infrared, you cannot see this thing, okay? And she said that she can see CO2. So it's just a bit of a joke. I just wanted to point out that the role of CO2, water vapor, is very important in the climate system. So I'm showing you two graphs, okay? Top and bottom. The top graph is actually temperature. The bottom is water vapor, okay? And I'm showing you the distribution from South Pole to the North Pole. And then in the vertical coordinates, it's actually going from 0 to about 20 kilometers, right? What I'm showing you is that temperature and water vapor at one instant of time, okay? It shows you that as you have more water vapor, the area tends to be warmer. As you have less water vapor, it tends to be cooler, okay? That shows you how close a relationship of temperature and water vapor is in the climate system. And then in terms of time, at least we have two satellite measurements. The blue curve is actually showing you the temperature measurement, and then the red curve is actually showing you the water vapor concentration in the atmosphere detected by the satellite radiometer, okay? They're pretty close relationship. Then I'm going to show you this because the ultimate things about science is about tests, right? You have a hypothesis, carbon dioxide increase. What does it do? increase the greenhouse effect, yes? So a paper that published 2 years or 3 years ago, indeed trying to quantify this issue. And they tend to find that the last few years, you tend to have this so-called flattening of the greenhouse effect, which I will show you by this graph. From 1980 to 1991 or so, there appears to be some kind of increase of the greenhouse effect. And then by the time you reach about 92, 93, if you keep plotting the greenhouse effect, it seems to be flat, going up and down. So what this is telling you is that if you study the energy flow in the climate system, that the last few decades it's been flattening. There's just, even though the carbon dioxide is rising, it's true, that one is still true, by the way. But the greenhouse effect has been flat. So what does it tell you? It tells you that carbon dioxide is actually playing a minor role in the total greenhouse effect in the climate system, really. Because this effect of flattening is caused by two things. The cancellation between the water vapor and the cloud effects, okay? But not controlled by carbon dioxide at all. This is actual measurements. If you don't like this, look at the result from Antarctica and Arctic. They measure something called the outgoing long-wave radiation. Satellite could do those things. It's showing you something like this. So I think in terms of testing the empirical effects of what carbon dioxide do to the system, it's fairly convincing that no such thing exists. And then when you come down to global warming, just remember too, every time they say that if I have more carbon dioxide, I'm going to warm the climate by a few degrees, let's say. But the few degree in the context of a city like a Boston, I'm basically showing you the daily temperature in Boston from January to December. Okay? And then they say the global warming going to change by 2 or 3 or 4 or 5 degrees Fahrenheit, let's say, on this scale. We go from anything from 10 degrees Fahrenheit to 80 degrees Fahrenheit. And we're talking about this tiny thing that is very hard to detect, even if you allow their theoretical speculation to be true. So in that, I'll just conclude that I'm going to protest. I'm going to save the Earth. I'm going to stop continental drift. Anyway, joking aside, the future of this plate tectonics is also studied, attempted. I don't think we should believe in this 250 million years in the future, but they will be united again, I guess, in 250 million years from now. So, is it true that most of these taxpayer-funded scientists are just honest and wanted to provide neutral and reliable data sets? That's really a serious question to ask. And then, just want to remind ourselves, in 1907, in publication of the American Meteorological Society, people talk about this already, that we should be honest, we should not be messing around with data, and so on and so forth. So I want to show you this case that is very, very outrageous. What I'm plotting here is 3 curves. 2 curves is basically the blue and the red curve. They are what you call the satellite temperature measurement of the global temperature. From about 1990 something to about, let's say, present time. It's going up and down, but it's flat, right? This is what the famous thing called the global warming hiatus. It's not warming up, while the carbon dioxide is still rising. And then another data set that shows is rising is produced by NASA Goddard Institute for Space Study. The 2 satellite data is measuring something from a layer about a few kilometers up from the atmosphere. What is measured by NASA GIS, Goddard Institute for Space Study, the green curve, is from the surface thermometer data. We don't believe that data is true, of course, by the way, so we're working on those class of problems. But here I want to refer to a case by the group called RSS. They are from Santa Rosa, somewhere here. They are actually showing that curve in 2016. And then I want to remind, because every time that in science, that if you can do as many independent measurements that you can, that is becoming more interesting. I just want to remind you on the middle panel, the RSS and the University of Alabama Huntsville data agree with each other. There's a flat trend. But there's actually a third data set that is measured by another technique, okay, from a Taiwanese group. They're actually using some very special technique of looking through the atmosphere and do that sort of thing, radio occultation for people who wants to know. It actually shows satellite flat trend, by the way. So what do? We have 3 data sets, 4 or 5 data sets. 3 of them kind of show flat here, right? Because they're measuring the atmosphere. And this guy from the surface showing the warming. So is it really true that this hiatus, this so-called hiatus, you understand this, right? If the temperature is not always coming, is rising, they actually consider this a disaster for them. Instead of saying that, hey, maybe we are wrong, carbon dioxide is not important. Oh, no, this will shake all their foundation. They don't like it. Okay? So they started to say that these are fantasy created by people like myself. Okay, so they have BBC say, what happened? What happened? We need to study this. And then you even have, sorry for the quote, but anyway, there are folks in scientific community talking among themselves saying that we're in trouble now because we cannot explain why the temperature is not warming up. So it shows you that they are worried internally. And even worse, a very famous professor by the name of Professor Phil Jones from UK was actually writing to his colleague from the UK Meteorological Met Office because they were making forecasts. They even forecast that the temperature will keep flat for about 2020. Remember this, okay? I'll make the point later. Because even forecast is showing that it's going to show flat. Because, you know, they want to show that they can predict this. Oh, we understood this thing, but it will warm again. You just wait. You just wait. It's going to warm again. And look what happened. 3 years later, RNS temperature now agree with the Goddard Institute for Space Study. So, if the data don't fit your theory, what do? You change the data, guys. Be smart. Why not? That's okay. So they were talking things like that. They're beginning to talk among themselves that maybe, you know, satellite data, by the way, is measuring something in the troposphere, like a few kilometers up the air. It's actually a good measurement because they're measuring something from the vibration of this oxygen molecule that is very uniform, okay? Because it's very same amount of constant, 21% everywhere. Carbon dioxide, there will be a lot in this room, few thousand parts per million. Outside is 400, things like that. It's very good. And then now they say the surface thermometer data that has all kinds of problems is okay. So this is the summary. When the data don't fit, you just change the data, okay? So I'll just propose this. I'm going to send this ransom note, right? Give us the dollar or you will fry, guys. You'll get all kinds of problems. Please pay here with IPCC. Then I'm going to get into another case that is very serious. This is very serious. The man on the right or left is Michael Mann, and then the other one is the famous Bill Nye, the science guy. Celebrity. But anyway, this is concerning a very serious problem. Michael Mann is well known and associated with a phenomenon called hockey stick temperature history. This is actually a paper that's been produced showing that the temperature could not change much from 1000 AD to 1900 AD, very flat, and then it warmed up from 1900 to now, zoom it up. Never mind the hiatus, of course. And then most people are studying this flat part. Okay? I produced a paper myself. In fact, my paper was the first one ever produced in 2003. Now, I want to focus in on the blade problem, okay? Let me show you. I wrote a scientific paper just to make a point to say that we study this issue carefully. And then I want to tell you that Michael Mann was very worried about this, so he put out in the blog saying that, oh, there's this so-called attack paper. In science, when somebody criticizes your work, you'll be very, very happy if you're an honest scientist. Because according to Michael Connolly, my good friend, saying that we learn more then, right? Instead of saying, oh, this guy is attacking me, he's from denial club, and so on and so forth. So he actually blamed that, I was trying to attack IPCC. No, Michael Mann, I was attacking your work, not IPCC. Really, he was so proud. He was so proud that he tried to stop my paper from publishing. He was influencing this American Geophysical Union that published that journal, Geophysical Research Letter, where I printed in 2004, calling them that I have violated copyright in my paper. Therefore, the paper shall not be published. Let me show you the problem. You can look here. It's a bit hard for me. Okay, left. Okay, from left to right, you have 3 data sets. Michael Mann 2002, Michael Mann et al. 2003, and Michael Mann and Joan 2003. And then the one to your right is my results. I try to emulate whether you can get this temperature change. This is actually the temperature change for the last 150 years or so, right? You notice that in less than 1.5 years, 2002 to about 2003, you notice that the N curve, the red curve, is what I want you to focus on. It keeps changing. It keeps going higher. Do you understand what it means? It's impossible. Under any data, any condition, the data could not change by 1 year, especially this one is 4-year filter. You smooth it out so you don't want to study the year-to-year changes, so you study the long-term changes. Do you understand? Mm-hmm. This is the part where nobody discussed this. I published a paper on this to point out that I consider this case is a scientific fraud, in my humble opinion. Okay? he came back and talked nonsense again. It's very sad. How many years already? 2004. Okay, you think about it. And he was very proud. There's actually a proof that he actually talked among himself that he was so proud. Really soon going to have this paper coming out, but I was so powerful. I'm Michael Mann. I'm able to stop him. Okay, because he was colluding with the American Geophysical Union Geophysical Research Ladder folks about able to stop me from printing. Unfortunately, I was rather smart by that time. Actually, I've gotten all the permission to redraw the figures and to show it the way I show it. Okay, there's nothing wrong with actually taking a science. Oh, another very simple point about science. You all believe, right? If you have a data that makes something, and then you've already published your paper, do you think that we should ask them to get the data so we can check their data? Do we agree? Raise your hand.
Yes.
And do you know what is the typical answer, right? No, the dog ate my homework. No, you cannot have it. If I give it to you, you just want to destroy my idea. That kind of work, okay? I'm not joking. This is how serious science is. And these are always their side that are doing that. If they ask ourselves, Michael Connolly and Ronan Connolly, that they want our data, please have the data. In fact, every time we publish, we make sure the data is already out there, right? You don't do things like that. And then he become actually delusional. He think that he's a Holocaust survivor. He claiming that we're doing things like this.
Let me ask our director for a second, if he can go on a wide shot, and I don't know if you can get everybody on all at once, but I wonder in the midst of your lecturing to your students, whether any of you, and I'm sorry, I don't want to get too touchy-feely here, but I mean, this is what our subject is about tonight. Anybody started to cry or broken down or just had an emotional moment where you were overcome? Anybody?
Yep.
Michael, I see you nodding.
Yep.
What happened?
Yep.
What happened?
Yep. Sometimes I'll be talking about not just the science, but the denial industry and the things that fossil fuel interests did to lead us astray that are so like what the tobacco industry did decades ago to lead us astray on the health impacts of tobacco. And I'll tear up, especially when I'm talking to an audience of young people, because what a terrible injustice we've done them, or we've allowed others to do them, by misleading them on what is arguably the greatest challenge we face as a civilization. Sometimes I tear up just describing that, talking about that.
Well, one of the ironies of this program is I can't recall a time I laughed as much as I did.
Laugh as much as it did. Yeah, this is what people that do things like this and kind of very strange. Too emotional, isn't it? You may call me emotional, but really, I sleep very well. So, you want to hear more authoritative statements from global warming? Now let's start with IPCC, US EPA, or global change research, right? IPCC is very fond of putting out this curve. They say that on your left, you have a lot of this orange line and the red curve, they are all model calculation. And then the black curve is actually observation. They can explain everything, okay? If they include the carbon dioxide. And then on the left, this blue one,
On the right.
include only the, on the right, yes. That you include only the volcano and the solar, it won't do anything because it deviates. And I have to tell you, if anybody have any understanding of statistics, this is actually an abuse of statistics. And also, statistics, I'm not interested. I'm interested in physics. You notice the unit that they plot. They always plot this thing called the temperature anomalies, which is a very strange word. It's actually a temperature deviation from some averages, okay? But if you plot in the actual temperature unit, the ice freezes at 0 degree, isn't it? The ice gets boiled at 100 degree. If you plot in absolute unit, look, the dotted line now is actually the observation, and then the data, the model calculation is all over the place. But when you do a temperature anomaly, you actually squeeze them together, you hide it so your data look very impressive. I think rule number 1 in science is that you don't oversell your results. So in fact, they should have show this plot, but they never ever show this plot. It took them a long time until 2012, the first plot like such kind appeared. It has to be done by amateur scientists, okay, to make those kind of plot. And of course myself, but I don't need to publish paper like that. So US Global Change Research, it's actually a well-known one because they are now making a fuss out of this report, right? Being something important and it's against President Trump, so on and so forth. But among the stuff that they show is that they take all those results from IPCC and they show you that, look, instead of temperature anomaly, they can plot the temperature unit in absolute unit, Fahrenheit actually. Somebody that really crazy, that they convert the unit of an anomaly, a change, to actual unit. That's how bad it is. EPA is doing the same thing. That is wrong actually, by the way. So I asked the question, where's the peer review? If, by the way, this is a phenomenon that is very serious. It's going to kill science, in my humble opinion, because it's not about peer review anymore. It's all power review system. And it's very, very urgent and very, very dangerous. If you care about science, you really need to speak out. So it's really true. It's from the basically anomalies. Instead of showing all those ranges, there's somebody foolish think that you can convert this into absolute unit, but these things are not representing that at all. Okay, I hope you understand that. And this is just another example to remind you. The model is all over the place. They have too much ice, too little ice, you know, that kind of stuff. When they have too much ice, okay, I'm going to melt some of the water and throw it into the ocean. It's showing you that the climate modeling is in a very big trouble state. Then, that was long ago, maybe about 10 years ago, but now I want to show you even more recent example. This is a very prestigious lecture in JPL and Caltech. Von Karman, Theodore von Karman is a very good fluid dynamicist from Caltech. That this guy was giving a talk, and he was talking about carbon dioxide and temperature change for 800,000 years from Antarctica. But the problem is, the ice core data is showing you the temperature anomaly, the difference. Do you understand? It's showing you the difference between certain mean period. So it's a change of a temperature. But this scientist, so-called scientist in 2017, was converting 0 to 32 degrees Fahrenheit. I hope you get it, please. It's just very simple kind of goofy mistake. I don't want to laugh at him, but it tells you that this is how delusional the whole field is. This is supposed to be an expert talking to public audience, because they want to make sure that you're more familiar, you can feel the temperature, right? You know this. But nonsense again. So this is the kind of important public policy question, right? If it's so important, why they keep pulling out all this stunt, graphical kind of stuff? Remember, I tell you, I don't believe in this persuasion business, you know. Science is all about evidence, 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 and data. So the question is, can the climate model simulate? If you think climate model is important, because that's what they use for policy, right? For next 100 years. They say now it doesn't matter. You don't even need to validate the model, actually, they say. All I care is that if I increase carbon dioxide, it's going to warm for the next 100 years. Okay? But let me do another test. Can we simulate something simple called the seasonal cycle in the climate temperature data? So I'll show you that if you plot the information of the seasonal cycle of the temperature, northern hemisphere temperature, from about 50 years, for 50 years, you plot something on the vertical axis called the amplitude, you know how large the season number is, and then the phase, the timing of the peak, whether the summer warming and winter cooling sort of thing, when it comes. You see that the data, the climate model data is all over the place. So let's see if they can hit the jackpot. Where is the observation, right? So the observation is right here. Oh, they miss it by a lot. It's bullseye, man. I'm going to throw my thing. I'm going to throw my dart. It's going to hit somebody, right? So season is very serious. Come on. Listen what I just told you. Yeah. The climate model cannot produce a seasonal cycle. And they tell you they know something about the climate system, isn't it? Okay? Then another serious scare that they always do is that they say, oh, the last 150,000 years ago, there's a period called the Eemian warm period. Because remember, now we're living in a period called interglacial, called the Holocene. And then 20,000 years ago, we live in an ice age, right? When the ice is about 2 miles thick in Boston and New York and reach as far south as Delaware, there's a lot of ice. So the big swing, the climate system going up and down. But every time they talk about season, every time they talk about other warm period, they use the Eemian, the 150,000 years ago, 115,000 years ago. But I want to remind you that it's completely different Eemian from now. Because now you have this solid curve. Our seasonal amplitude changed by only 90 watt per meter square. But Eemian the orbit was less circular, so it's more eccentric. So therefore, the seasonal cycle is changed by 230 watts. So every time they talk about even Eemian being equivalent, like because they say Eemian, all the Greenland ice sheets melt. But that's a very different condition from now. It doesn't mean that the Greenland ice sheet would melt again, of course. And then I want to do another test about climate model. Because according to them, that if one model is wrong, that's okay. You know why? Because we're taking a lot of averages, right? This is actually a quote that is slightly embarrassing. I don't wish to embarrassing him, but he actually say it. It's by a professor of chemistry from Rice University, of course a Nobel Prize, that he say, you know, the sobering conclusion about future warming using climate model are based on these elaborate models, right? It's usually wise to be suspicious of computer model of complex situation, but we're not talking about one scientist model. It's a number of programs give similar results. With that, let me challenge Professor Ko. That I ask you to look. If I have all this bunch of passenger jets, do you want to know what the average passenger jets is? And if I show you, would you go on it, right? So it's mean that if you average all the result that is wrong, it doesn't mean that you're going to get it right, right? You're going to get it more wronger. I don't know what it is. Here's what the average passenger jet look like, right? So I don't think we want to take that jet, right? I hope we can send our go on that one. So it's a very simple proposition. If you really think that you can solve the problem like that, you give me a faster computer, right? But I want to point out that there are many follies. Just two examples to show you the problem of current day, today, 2019. What kind of problem we have in climate model? Here's one example. The first example is to ask the question, how well can the GCM, which is the global circulation model, which is the global climate model, right? How well can it simulate cloud structure? On your right is observation. On your left is a GCM, right? The computer model. It really don't agree too well, isn't it? No. Right? You cannot simulate the cloud. You're going from 90 South Pole to North Pole, you go vertical height, right? From surface to basically high up in stratosphere or troposphere, right? It's very bad. And then you ask a simple thing. How about sea surface temperature? More or less similar. If you compare, this is actually a calculation, and then you compare with the difference with the observation, you can see that large part of the Pacific Ocean and Atlantic Ocean are cool by relative to actual observation for 5 degrees Celsius. That's quite large, by the way. So for climate model, I have very simple proposition. That most of the time, they got the right result for the wrong reason. And then people like to say GIGO effect. The well-known GIGO effect is garbage in, garbage out. For me, that's not a problem. If it's garbage in, garbage out, I just ignore it, right? It's garbage in, gospel out is the problem. I'm very far near the end now, so please be patient. The thing I want to show now is basically about sun-climate connection, which is my area of study. The picture is just to give you the essence that the sun is powering all the energetic in the system. The typical story how IPCC would say sun is not important is to show you graph like this. They use a concept called radiative forcing. According to them, carbon dioxide gives you 1.82 watt per meter square over the last 260 years. And then the sun gives you only 0.04 watt per meter square. Game's over, right? Really, they win. I clap hand because if this is true, if this is how the climate function, is to look at the change in the system all the time and not even think about season. This is why they avoid season, okay? And that's the reason. The same information, you can plot it like this. Because the sun is indeed the big giant gorilla in the climate system. This is actually a very nice picture of the sun in X-ray taken by some colleagues from my workplace in X-ray. So to finish off, I want to show you another way. Those that came and saw me last night at the library in a church in Woodside, California, that I show a way to study sun-climate connection, which is to say that because the thermometer data is very confused, if you take the urban data, you don't know what it means, so you take some rural station, so you study that to see whether there's any implication of the sun effect there. I think I show that there is some effect, and we have published paper on that. This is another way to look at it. So my proposal for tonight is to say that if you want to study the sun effects on this climate system, you better don't go and study the temperature during the night, isn't it? Am I right? So you study during the daytime maximum. That's basically the question. I think I should skip a lot of this slide, but I want to show you a bottom line. It's not a good idea at all to study the sun, the temperature during the night for the sun effect. Because at the night, you tend to form this thing that there's a stuff near the surface and the warm stuff. So you have what you call a boundary layer. So the atmosphere and the surface are not so connected because the thermometer is sitting on the surface. During daytime, it's a lot more easier to study this, right? Because it's more connected to the surface. Okay? So it's really an amazing simplicity. It's just something in the hunch that I say. You study the sun effect during daytime maximum daily temperature. If actually not so cloudy, guess what happened? You might be able to see something like this. The blue curve is the temperature maximum, the daily temperature maximum from the United States versus the solar irradiance, the red curve. If you don't believe that, you also can see that in Canada. If you don't believe that, you can see roughly of that picture in Mexico. Okay? And then finally, because the metric that I measure is called the solar irradiance, it's actually giving you information about the sun's incoming radiation more or less near the surface, more or less near the atmosphere at the top. There's a basic problem that we have a problem because this is the hardest science problem for climatology, which is to understand cloud. What does it do? What does it change more? Because in cloud there's so many types, that sort of thing. So do we have evidence to see that the effect of the sun at this upper atmosphere reach all the way to the surface? That is extremely hard to find the data. It turns out that I was able to find one set of data, okay, that shows that the radiation does reach the surface. If I plot some of the temperature data with the ground solar radiation, it shows some kind of correlation, similar picture that you cold from this period, you warm 1930s, 40s, you cool in the 70s, you warm up again, okay? So my takeaway message tonight is this. There are simply no experimental data to support the view that the Earth is changing in a very strange way or dangerous way. By carbon dioxide, by the sun, by whoever, And then one thing that we are sure, carbon dioxide is just a big player in the climate system. So the idea that you can have this carbon dioxide knob, that turning up and down is just an illusion, right? Because they imagine that this is a climate knob, that you just adjust the thermometer up and down. I would say X, right? Basically not true. And I don't know how many of you know about this case or you are interested. The US EPA apparently have to rule that the carbon dioxide is an air pollutant. And we have this conservative justice that passed away, Justice Scalia, during 2007, actually April 7, the decision was reached in US Supreme Court, that rules that carbon dioxide is an air pollutant and therefore US EPA must regulate. They have no other options. This is a very sad decision that I think we should try to fight. But according to Justice Scalia, if you think that everything airborne from frisbee to flatulent qualify as air pollutant, right? If CO2 is an air pollutant, then even frisbee and flatulent should be qualified as air pollutant. So therefore, this is a statute that defies common sense. So a bit of update is actually Sam Alito just gave a talk somewhere in Claremont Colleges a few years ago that simply say that really carbon dioxide is never ever a pollutant. This is very strange. They want to change the reality by using this human law, not the physical law. CO2 could never ever be an air pollutant. This is really a messy business, by the way. This is telling you something is very strange here. And then my third point is that the sun is, in my humble opinion, is primary driver of climate change, and one should study as much as possible. Again, I do not make the claim that we have found the evidence. I'm merely showing you that there's a lot of interesting hint and one should study it and understand the exact way in which the sun affects the Earth system, including sea level change, all this other stuff. And then you have to remember, climate model, that famous thing, that tools, they actually come at tool. I say it's so misleading. It's really not like knife at all, where you can use to chop, you can do so many things, including killing people. You can do so many things. This climate model is almost useless, in my humble opinion. It's supposed to be some kind of a pedagogical tool, some tool to learn, But it's not for forecasting at all. It's simply not ready, right? Because they cannot represent a lot of this physics and chemistry and all this problem. That's what the problem in climate model. It can never be used for public policy, no matter how many people say about it, no matter what the Supreme Court is saying. This is my last slide. My last slide is to quote a good friend of mine by the name of Professor Richard Lindzen, retired already from MIT because he's a bit fed up. He needs a rest. He really said that this problem is rather serious, really. He said when the historian, what historian would definitely wonder about in the future century is how deeply flawed logic, obscured by shrewd unrelenting propaganda, actually enable a coalition of powerful special interests to convince nearly everyone, except lucky few like us, right, in the world that carbon dioxide from human industry was a dangerous, planet-destroying toxin. It will be remembered as the greatest mass delusion in the history of the world, that carbon dioxide, CO2, the life of plants, was considered at time to be a deadly poison. Okay? I finish. Thank you.
Thank you, Dr. Soon. We're quite pleased to have Dr. Bloom, who has kindly agreed to comment. He is Professor Emeritus at the Kavli Institute for Particle Astrophysics and Cosmology at the Stanford Linear Accelerator Laboratory at Stanford University. He's a fellow of the American Physical Society. He was a member of the SLAC, that's the Linear Laboratory team, with Jerome Friedman, Henry Kendall, and Richard Taylor, who received the Nobel Prize in Physics. He received his PhD in physics from the California Institute of Technology. He's the author of numerous scientific papers and the recipient of the Senior Scientist Award from the Alexander von Humboldt Foundation. Dr. Bloom?
Well, good evening, everyone. And I think I appreciate greatly Dr. Soon's discussion, and mine will be more boring. So I was trained as a particle physicist in particle research for about 25 years. I led a number of projects and built a few large experiments during this phase of my research, and I have published extensively in the field. Particle physics is a laboratory science. That is, experiments can be repeated in a controlled way by more than one group to check results in different laboratories. Research is open with free exchange of ideas and results. Particle theory is held to high standards of falsifiability, except for string theory, which has essentially nothing to predict about current and past laboratory-based experiments. Since particle physics discoveries usually have no direct impact on society or our economy for many years, and a recent exemption actually was the World Wide Web that was invented by particle physicists at CERN in Geneva, Switzerland, and it was brought to SLAC by a physicist in my group by the name of Paul Kuntz. And SLAC, he made SLAC the first website in the United States. National politics has a small footprint on our work, and the U.S. budget is about $1 billion a year for the DOE and NSF. So we are left to do our work. I was a member of the team, as David mentioned, that discovered quarks as the basic constituents of the proton and neutron. This was accomplished using high-energy electron scattering experiments on protons and neutrons at SLAC from 1967 to about 1972. It took about 20 years for the three senior leaders of our team, Friedman, Kendall, and Taylor, to win the Nobel Prize in 1990 for this great advance in fundamental physics. Much work was done all over the world to verify the quark paradigm before the prize was given. Many experiments and verified theoretical predictions have proven quarks to be one of the fundamental building blocks of matter. In about 1990, I changed my field of research to particle astrophysics and astrophysics. I was active in astrophysics for 25 years and helped build two satellite-based telescopes, an X-ray telescope and a gamma ray telescope. and made many observations and published extensively in the field. Astronomy astrophysics has a minimal impact, again, on society and our economy in the short term. However, this field of study has more impact politically than particle physics due to the much larger budget of NASA as compared to the U.S. particle physics budget, about a factor of 10. And much of this money goes to private companies to support the NASA mission of space exploration and science. So again, even with this larger 10 billion, 15 billion number, national politics have a relatively minor impact on our scientific work. There are no alarmists and deniers about theories in astronomy and astrophysics. The closest the theory comes to predicting the end of humanity, possibly in the near future, is a direct asteroid hit, which implies the need to get early warning using astronomical instruments. Nobody disagrees with this precaution, and the cost for due diligence is not large. Astrophysics is an observational science. One can rarely repeat laboratory-based experiments to check on astrophysical observation of the stars, galaxies, our galaxy, galaxy clusters, cosmic microwave background, etc. Considerable input from physics, like classical physics, quantum mechanics, general relativity, that is verified in laboratory experiments and astronomical observations and expected to hold true throughout the universe is very important in this field. It's used extensively. Astrophysics is an observational science Astrophysics is an observational science that deals with complex, nonlinear phenomena like the origin and evolution of the universe. Research is open with free exchange of ideas and results. In many cases, observational data is open to the public. You can go to the web and download this data yourself, and you can get help from NASA to analyze the data, and you can publish it if you get the peer review. And people, outside those that actually build the instruments and take the observations directly do this work. Many similar objects to study in astronomers and astrophysics search for patterns. So there's thousands of objects, and you can look for statistical similarities and such. This has a similarity to botany, except botany involves direct accessible specimens. Some success with theory, for example, general relativity's description of the universe, stellar modeling, and other examples. But theory usually incorporates a lot of phenomenology and frequently needs serious corrections as more observations are made. It is hard to make predictions that can accommodate new data, even though this phenomenology can be based on observations of many different examples of a class of objects. For example, stars, black holes, active galactic nuclei, etc. Astrophysical theories are difficult to falsify. Frequently, when new measurements contradict a theory, modifications to the theory are made to incorporate the new data without changing the basic paradigm. An example of this is the Big Bang cosmology, which in its original form did not incorporate dark matter or dark energy until after they were well established via independent astrophysical and astronomical observations. Even though it is difficult to apply falsification criteria to astronomical theories, progress is made through open and vigorous discussion and cross-fertilization of different theories based on existing observational data and predictions for future observations. In my view, this type of openness is a prerequisite for keeping a scientific discipline from going off the rails. After I retired from Stanford in 2016, I started to study natural and anthropogenic climate change. I have read, listened, I've learned a lot. I'm like a graduate student again, in a certain way. But I am not an expert near the level of Dr. Soon. I have not published nor done original research in this field. Climatology is an observational science. We have one Earth and one climate. Climate is a hopelessly complex, nonlinear theory. As such, the Earth's climate is chaotic on all timescales. From short-term weather to long-term climate, there is no natural way to separate weather from climate at some well-determined timescale. The nonlinear nature of the problem implies that predicting the future only weakly depends on what has been observed in the past. The only way to potentially predict the future with current technology is via computer simulations of what will happen based on fitting past Earth climate using classical physics and quantum mechanical inputs. For example, putting in the greenhouse effect of CO2. And then letting time move to the future in the simulation. Considerable input from physics, again, is necessary, classical physics, quantum mechanics, which has been separately verified. There are many climate historical artifacts to study. Willie's talked about a number of them. Ice cores, historic temperature readings, etc. A large number. None of this history necessarily applies to the future, but it is most useful to testing models that hope to predict the future. Reproducibility of historical data has been an issue with frequent upgrading, changing of historic data sets, depending on the bias of the investigator producing the new and better data set. Unfortunately, frequently climate data is not open. Willie spoke to these issues. It's only sketchy success with theory, which incorporates phenomenology and gross approximation and frequently needs serious corrections as more observations are made and new climate physics is learned. It has proven almost impossible to make predictions that can successfully accommodate new data given present technology. Just reference Al Gore, and I'll give you another example below. Research is contentious with too much proprietary delay of ideas and results. Scientists are labeled as alarmists and deniers, and particularly deniers are attacked in the mainstream media and by many politicians, no matter what the credentials of the researcher. It is difficult to falsify climate change predictions, which is made much more difficult by the highly politically charged culture of the field. Politicians are clearly heavily in this mix. In my view, this lack of civil exchange and openness in research is sending climate change science off the rails. So, climatology in particular, the study of natural and anthropogenic climate change, has a major impact on our society and our economy in the short and longer term. Getting the science right is thus important for obvious societal reasons. Politics should be kept at arm's length to allow the scientists to openly and dispassionately do their work. So now I'd like to talk a little bit about the IPCC reports of pending doom. The worst case IPCC models predict runaway heating of the Earth over the next 50 plus years due to anthropogenic driven climate change, greenhouse gases, and other effects. The IPCC recommendations, mirrored by mainstream media and by many politicians, demand very expensive and disruptive actions starting now to limit the emission of greenhouse gases to avoid catastrophe. Many experimental results do not support this urgency of action. They indicate that we likely have more time to reduce greenhouse gas emissions, and this is a good thing. A good book that gives a more moderate and, in my view, realistic view is Beyond Smoke and Mirrors by Professor Burton Richter, winner of the Nobel Prize in Physics in 1976, recently deceased, and he was a colleague of mine who I knew well. It's an educational book for the interested layman. One of my favorite papers is by John R. Christie et al. It's called Examination of Space-Based Bulk Atmosphere Temperatures Used in Climate Research. I found this to be an outstanding and very careful paper, very difficult to go through. It has a tremendous number of details. The paper shows how difficult and complicated it is to measure the Earth's temperature. Some of my colleagues at SLAC, oh, just average all these temperature, measurements. It's trivial. Actually said, it's trivial. Not trivial. Systematic errors are a major issue. In this paper, the authors state that models are over-predicting temperature increase in the tropical zone, that's plus or minus 20 degrees latitude, and they measure the profile as you go off the Earth up, and they show how the climate models have a very difficult time reproducing that. And they say, we would hypothesize that a misrepresentation in the models of the basic model physics of the tropical hydrologic cycle, that is water vapor, precipitation, physics, and cloud feedbacks are likely candidates for this agreement. So here is a graph which was presented by John Christie at his testimony to Congress in February 2016. You have a copy of his testimony in the materials that were given to you. It really is a great thing to read. It's easy to read, actually. And compares the model to data. And you see the data is the dots and squares. And they go over a time period for satellite data 1979 to 2015, and balloon temperature data 1979 to 2005. And then some average of all the IPCC models are given as a red curve. And you see that they are dramatically over-predicting today the measurement of the balloon and the satellites. And this is quite a large factor. Interestingly enough, there's this Russian model I indicated, which does pretty well. So there's a lot of freedom. It has to do with the sensitivity to the forcing from carbon dioxide. And if you make that forcing not so much, you can get better agreement with the data. Now here's an example, an unfortunate example, of climate change science off the rails. John Christie believes his office floor at the University of Alabama in Huntsville was targeted by gunshots over the National March for Science weekend in April 2017. When some people cannot argue facts, they resort to violence to get their way. It doesn't matter that we don't deny global warming. The fact we disagree with its seriousness and the level of human involvement in warming is enough to send some radicals into a tizzy. That's a quote from Dr. Roy Spencer, commenting to the press about this incident. Thank you for your attention.
I would like you to present the best argument that you found most persuasive to support the dangerous anthropogenic global warming, and also one argument, the best one, against it, that you find the most persuasive. One for, one against. And also I'd like to ask you, what is the, in the scientific community, what percentage of scientists truly are scared and they believe that we're destroying the planet because of the CO2 emissions? Thank you.
You want to start?
Okay, I can start first. In terms of their most convincing argument, it's a hard task. But I think the best one is probably the one I showed, that correlation of temperature with the carbon dioxide. But unfortunately, I already know the problem there is the carbon dioxide measurement is okay. It's the global temperature measurement that is completely controlled by mostly the urban heat island effect, for example. So it's not a valid data in that sense.
The heat island effect is
Yes.
the effect of urban areas on temperature.
On temperature measurement, yeah, it goes up. That's why if you use the, let's say, satellite data, you know that it's not going to show the effect. So sorry, I give them the best case I can. And then the most convincing case, I guess, for this non-alarm is basically that you just look up the planet Earth. It's actually over the last, we have data for maybe almost 20, 30 years now, that if you measure the leaf index, the greenness of the planet, you can do that kind of measurement reasonably well, errors and a lot of stuff, but we know, we can monitor. The planet does get greener. So that's essentially telling you that carbon dioxide effect, you cannot find it in terms of temperature or weather or polar bear, whatever you want, right? Pizza, number of pizza being eaten by algae. But it's basically that it's a very benign gas. It's a beneficial gas for the human. So that's about all I can say, right?
Elliot, anything?
Well, to me, falsifiability is very important in testing theories, and as I mentioned, it's difficult to do in climate change, but I'm used to that because astrophysics has similar issues. And but I was very impressed by this John Christie et al. Paper, and to me that shows that the temperature isn't rising very much as compared to what 97% of the scientists say is happening. And I, having carefully gone over his paper, I agree that his results are probably correct. With respect to dangers, I think that Bert Richter's book is a good resource there. What he talks about is the growth rate of fossil fuel use of a modest amount, and how it goes for the next 50, 60, 80 years, and what we would be facing. There's, urban legend about New York City in about 1915, and there was all this horse manure in the streets.
Oh, yeah.
They were removing 2.5 tons of horse manure a day. And then people started projecting, well, if this keeps on going like this, we're going to be up to our eyeballs in horse manure every day.
Yep.
And something came along, a new technology called the internal combustion engine and fossil fuels. And that really solved the problem for a long time. So that's, to me, the issue.
Yeah, or the whale oil, right? Imagine killing all the whales. We come from a fully renewable, 100% renewable, a few hundred years back. We go now and then come along, we found fossil fuel, we use it, and then now they want us to go back. It makes sense, actually.
Yeah, Richter doesn't like
How
renewables.
about the lady right here? Oh, okay.
Dr. Soon, I don't think I caught what your intention was on one data pair set you presented, namely on temperature and water or water vapor concentrations. And forgive me, I think I must have misunderstood. You appeared to be saying that temperature was a function of water vapor. Isn't it the other way around? The higher the temperature, the higher the dew point?
Well, you could be right on that point too, but it depends on what causes each of the variable first. So example, again, that's exactly a very good question, right? For example, I would say that, for example, one of my hypotheses, that's the way that the sun will hit the climate system is actually causing the water vapor to evaporate and then therefore couple with the temperature field, right? Something to that extent. That needs to be studied carefully. But just to say that to dismiss it out of hand is always a very bad idea in that sense. That's about all I say, actually. Thank you.
I think the scariest thing for me in this is that this isn't the first time I've seen science co-opted by politics. I was a scientist when the AIDS theory was politicized. As a scientist currently, what do you think we can do to change this, to get people back to science-based, testing-based, laboratory-based work? It really does scare me because the last good big project was the Manhattan Project, in my opinion. of the big.
Well, Elliot, maybe you first.
Well, a lot of this has to do with the scientists themselves, and, you know, the training, at least that I had as a scientist, was these ideas of openness and sharing data, etc., that I talked about. And to me, that is essential to making progress. Now, there are models that one could have, like the Manhattan Project. Doesn't have to be like the Manhattan Project, not be that big, but one could think about having national laboratory where you had a mixture of people and a very strong director who kept the peace and herded the cats, and which had resources in computing and other resources, travel money, etc. And it would be a team effort, a large team effort. One thing that strikes me about the efforts in climate change is that they tend to be more individual, investigator-driven, and this is a very big problem for that. It seems to me a more organized way of doing it, which is, let's say, builds on history, would be useful.
My very brief reply is to talk about these issues and please tell more people, for example, get more books from Independent Institute and talk to all of us. Spread the news about this question. If they say that global warming is true, ask them, how do you know that? Have you looked at the temperature record?
So do you find that the scientists that are siding with global warming are actually true climate scientists?
Well, I haven't had a lot of experience with scientists of that type, but I have had experience who are climatologists, but I've had experience with colleagues who, for example, wouldn't allow me to invite a skeptic scientist to talk at a colloquium.
Yep.
And I do have friends who won't come to talks like this because they say a denier is talking. Okay, so this is, I think and if you look at the media, you have to believe that there's just a tremendous amount of pressure in one direction.
My short answer is that there are some really good climate scientists still around and believe in this IPCC global warming paradigm. But I would say majority of them are not real scientists, in my humble opinion, because you know why? They don't share data, they don't want to discuss, they don't debate, they don't do everything that scientists is supposed to do. And that is a problem. And I don't understand that, actually. I like them to talk to, things like that. It's terrible.
So is there anybody doing anything to help the children? Because I know with my kids growing up, I mean, their math equations now are done with equations that are presuming that climate science, that the false science is true. So my kid, I mean, they're getting brainwashed. They're doing these carbon dioxide equations and how much can you do and how much, you know, what are your parents doing wrong? That's their math. What are they doing wrong? How are they harming the planet? With the assumption that all of this global warming is absolutely true. And the books are getting written that way. Is there anything, are there any scientists out there that are changing that wave? Because these kids coming forward are just brainwashed. They want to cry, you know, with what they think's going on.
I'll say something. It is indeed very alarming that you have really, this process has began, I would say, already decades ago. The train has left this, but then it's really never too late just to realize that these people who want to insist that this paradigm of global warming, climate change is disastrous, is going to kill the planet, and so on and so forth, and then teach them in school, and then teach only a very one-sided direction. The only thing I'm against is that one-sidedness. Yes, remember that, right? I don't say that I'm right, but all I'm saying, you have to provide a lot more balance to that. And not only that, without that perspective, these kids are not able of any critical thinking. I have to say, your own sister is doing some of that. I myself is going to a camp constitution next week, right? We're trying our best. Some kids want to come, good. It's a small camp, but you can tell more people that you should set up more camp like that to teach kids in the summer. I don't mind coming. I mean, I don't mind doing that, talking to kids, but truly, it's very, very important. They already many steps ahead. Some of my colleagues from Ireland realize that they have started this thing called Green School project, all from the United Nations and the Greenpeace type of stuff, already way back in 1997. US, lucky that we only started 2009, for example, this Green School thing. And if you look at the syllabus, it's really scary. These kids are all beginning to talk about, you know, no point of doing this. We're going to go protest every Friday and blah, blah, blah. And this is actually crazy. And they are, by the way, I have checked this issue. For example, the most famous in this movement is Greta Thunberg. And there is a link back to Al Gore's group. If you want to know more, please ask me. I've done a lot of research on this topic. But let's not get into that now. And then David might say this is too controversial.
Dr. Sun, great talk. Dr. Blue mentioned some Russian work. I don't know if you're familiar with a paper by Dmitry Sudakrov in November of 2009, in which he proposed some pretty logical reasons why CO2 is a lagging indicator of temperature variation, not a leading indicator. And what he says is that as the planet warms up due to the increased sun activity, the oceans absorb less carbon dioxide, you get more CO2 during the next cooling cycle, which is going to occur when will be much more dangerous to the planet. Then as a lagging indicator, the CO2 will drop. Are you familiar with that paper, and do you agree?
Anyone that try to propose something as complex as a climate and claim that they have known all of that, I'm a bit skeptical. But it's in general. The question is basically, what is control the amount of carbon dioxide in the atmosphere? Clearly that the ocean has something to do with it, right? It's a bit like your Coca-Cola, no? It's hot Coca-Cola that all no more gas. I mean, and then all the CO2 go into the air. And that effect is real. Unfortunately, the change in science is all about number, not enough. But there is a portion of it, is the carbon dioxide changes is caused by changes of the warming of the ocean, for example, right? But on a very long orbital timescale, let's say every 100,000 years, the ice core data show convincingly that every time it is the carbon temperature that is changing first, and then the carbon dioxide in the system, in the biosphere, in the ocean, in the land surfaces respond to it up and down consistently for the last 800,000 years. Unfortunately, Al Gore's TV producer, Laurie David, published a children book for age, 5 to 15, that try to put the graph, label the graph in the opposite way, saying that it's the carbon dioxide going first and then temperature respond. Again, ask me, I have graph to show, I can give 1,000 more talks. Anyway, good enough. Thank you.
Thanks again for your talk. I was wondering, we don't hear anything about the CFCs anymore, and I was wondering what an entire industry was changed. I mean, all the refrigerants and Safeways and Albertsons and our air conditioners have been changed because of what they told us about CFCs in the early 90s. How come we don't hear anything more about that when they're continuing to vent CFCs, R12, R22 in other places besides the United States?
I do have an answer for that. Let me state my best understanding. This CFC, the problem is actually to ban it is to basically say it destroys the ozone in the stratosphere, right? Very simple answer. Ozone, you have 90% in the stratosphere, 10% in the troposphere, okay? And they've been always focusing that it's because of CFC. There's details about attaching to ice particle and break the chlorines, and then chlorines reactive and break the ozone in the stratosphere. I just say forget about all of that. Let's do a thought experiment. Einstein says it's a Gadekan experiment. Take all the carbon O3, the ozone out, and ask yourself if the ozone will come back at all, even if we have some CFC in the atmosphere. How long you guys it takes that you're going to come back? How long? Want to guess? 9 days. You're too quick. It's actually very short. It's not 10,000 years, not 10,000, it's not 1,000 years, it's not 100, it's not 10. It's about 150 days. The time constant is very fast. What they block your mind is, that's why I tell you that protocol, that policy was not necessary. Right. If you study history, it was because DuPont was running out of the patent for this control of CFC, so they had to come up with HFC and all these other alternatives. It's terrible manipulation. And so every time when they say that CFC is a Montreal Protocol, 1987, it's the best example of how humanity, all kumbaya, come together and solve the rest of the world problem. There's never been a problem in a real sense. I'm very sad to say that because I don't understand what the fuss is all about. It's really dangerous, actually.
About money.
Yeah. You know why you can get this back, right? Because they tell you as long as you cannot turn off the sun, the process of making ozone is very efficient and very effective. No matter Al Gore cry and whatever you want to do, Michael Mann want to cry, you cannot do anything. The ozone will come back very fast. 150 days. That's all it is.
Do you have a question, Sylvia?
Actually, a follow-up on your ocean question and the ocean warming issues. We hear about that a lot as a cause, and you haven't really addressed that, except in the last point, it's perhaps a following indicator. Do you have any further reactions to those that claim that the ocean and the dying coral in the seas is evidence of fast climate change?
If I understand your question correctly, I hope you understand what I just did in the experimental stuff on ocean acidification. Yeah. I mean, that's essentially trying to address that aspect of the problem. Okay? That, in fact, okay, I have a very cute one. This is correct, by the way. Everything I say is more or less correct. It's basically say that for that problem, for that class of problem, I want to say, do you want to outlaw the rain from falling down into the ocean? You want to know why, right? Because the acidity of the rainwater is, if you measure acidity, it's on a pH scale of 0 to 7 to 14. 0 to 7 is acidic, 7 to 14 is basic. The rainwater pH is, and it's on a log scale, logarithms, right? Every unit is factor of 10. So rainwater is 5.5. We're very acidic. The average ocean is about very more basic, 8.3, 8.5 roughly. And then deep in the, also do you want to outlaw the, what you call, the water, deep water is actually very, they're upwelling, exactly. And they are very acidic. You got to stop that from doing that because you mix it up, you're going to acidify, isn't it? It's actually very crazy proposition. I study into the history of this thing. I'll tell you more about it if you want to know. It started with the oil company, and start oil, blah, 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 because, you know, all kinds of issues. We all have studied that question, of course.
What percentage of the land-based temperature monitoring sites are properly sited so that they're not influenced by abnormal heat sources?
That's your question.
Yes. It's a very good question. We are doing some of the work right now, and I think better that we report back some other time. Unfortunately, I think a lot of the station that is actually in big city is probably not as useful anymore in some sense. And so you try to look for places where you actually can, you think that probably will have some meaning. Because remember, when you're measuring that, you're not measuring climate, isn't it? You're not measuring anything, quote unquote, temperature changes. You are measuring something related to concrete, all kinds of building, related to the shades, related to all this other stuff that actually have nothing to do with the natural system in some sense. Well, depends on how you define natural system. Human are the most natural thing you can find, right? We are nature, actually.
You know, I don't know much about carbon dioxide or what it's doing, but I do know that there's a lot of concern about the water level going up with the sea melting, the North Pole, et cetera. What's your take on that? Is this, I need to find out if I should sell my beach house.
We talked a bit about that yesterday. I don't want to squeeze that into this talk or else you'll go crazy, right? Because so many topics. And they will kick me out anyway. We have a video that probably you asked Terry Gagnon. I think we have information on sea level and all these things that we're studying. But the most important thing to remember that they make the claim, by the way, there's a lot of claim out there. A lot of this claim by quote-unquote peer-reviewed paper by all these famous scientists and so on and so forth that says that the sea level have accelerated the change, the sea level rise. But I beg to differ. You really need to look at the data and how they acquire the data, so on and so forth. There's just simply no such evidence exists to say that sea level is accelerating. And there's a lot of confusion in this issue. And one of the hardest part for scientists to do is to understand how does the ice sheets and glacier play a role in the sea level changes, okay? But I just give you an idea. The Earth system, this is stuff that you really need to know geology, you need to do all this other work, okay? I just give you a simple idea that a lot of the time they think that it requires that you have a lot of ice sheets, big ice sheets to provide the melt water. I found out that if you want to, and then I want to ask another question. How much can the sea level changes all by itself without, let's say, ice sheets from water source? You can raise the sea level by thermal expansion effect, meaning when it's hotter, it expands a little bit, isn't it? Or you can change the volume of your ocean, or you can actually melt ice that is locked in the land or someplace and drop this water go in. But I want to understand the most basic question. How much can the sea level change without an ice sheet, without a water source? It's called a eustatic sea level. It turns out that down the coastal region and all this underneath ocean, where especially a coastal slope, is quite porous. And so you pick a place, let's say in some long geological time, a few 100 million years ago, for example, where there's no ice sheets in the pole, north and south, and then you try to determine, ask the question, how much sea level changed then? It actually changed by as large as 60 meters. That's a lot. Okay? That just tells you that you don't even require the meltwater to account for some of these numbers. Because we know that ice age, last glacial maximum to now is about 120 meters. So half of it could be even explained by something else, which means the Earth system is too complex, really. Okay? So, but sea level change, long story short, well, actually, Fred Singer talked a bit about sea level change in this book, I think.
My question is simple. What can we do to change, to affect the change? Like in California here, it's, you have a Congress that's like not representative of the people. I mean, people want one thing, they do something, they do their own thing. How can we affect change?
I don't mind saying something. Sir, I think you have a lot of power in you. If I can do this, you can do this. Take a few of the slides that you're comfortable with, talk to the kids, go to a supermarket, everything. Just talk and tell them, Debbie is one of the best. My good friend Debbie, the sister, is here. Just talk to everybody about this issue. They keep talking about global warming. You ask them, have you seen the data? Do you know that thermometer data, some of them is not so good?
They don't look at the data though.
Well, that's the problem. They use word, they use emotion, they use all this other stuff. We have to overcome that. I mean, especially school teachers who are supposed to be more responsible, George, right? I just think that you have to say something instead of just sit around and not say anything and understand this problem. Say something.
Yeah, related question. How many trillions of hours of brain power have been wasted on this, and what would be better places to spend this human creativity and brain power?
Wow.
Well, this is a problem won't go away, obviously.
Yeah.
And it'd be nice if it was addressed in a more rational perspective. That's my position.
You've both made the point that the dynamics of water vapor in the atmosphere is more important than CO2 and actually dominates or should dominate in the models. So you would expect that the scientists worldwide would be focusing their efforts on improving the modeling of water vapor in these models. Is that happening? Are we getting an international concentration on this problem, or what?
Okay, please, I answer this, yes? In simple word, no. In fact, if you ask me today, this is part of the reason I continue to be activated on this issue. The state of the science today is very embarrassing. We're not really forward at all. We're walking backward like doing a moon dance. I give you an example. In 2000, year 2000, I was already just a postdoc, and I went to this international conference doing an invited talk. And I was outlining all the fundamental problem on climate modeling, like not having the hydrology right, by showing you that even for the cloud cover, when they quote unquote, they try to represent cloud cover, it's an equation that they just tune some of the numbers they want to use, okay? Like showing that the ocean thinks it's just crazy, it's just, you know, the circulation's supposed to go this way, they go backward, all this sort of thing, right? And that's 2000. I have a list of, let's say, 14 problems. You ask me today, how many of those 14 problems are improved or studied carefully? I would say none. It's going backward. I remember that conference very well because you know why? The person at that conference meeting that was very angry at me was IPCC chairman, Sir John Houghton. He said, how dare you criticize IPCC and all that stuff? I say, why not, sir? I say the reason, and they say, oh, we know about all this problem. I say, oh, thank you very much, you know about the problem. Because some of the problem does go back a long way, even 60s. For example, they don't have enough wave heating so that the stratosphere is always too cool. So when you compare with observation, it's completely off. They say, it doesn't matter, I'm just going to tune it and change and study the perturbation, a change of it, so therefore I don't need to know what the true state of the thing is. That's the way they behave. They are against it. And I answer Sir John Houghton, I say, unfortunately, sir, all this problem will remain unresolved for a very long time if I don't talk about this thing. And you can imagine, is it about science? I was just a postdoc. I'm not threatening, I'm just saying what I understand. And I published a paper on that too, of course, with Professor Kirill Kondratyev, which is the rector of St. Petersburg University, a good Russian scientist.
I want to thank our speakers for tonight, and if you join me.